Right. Okay, in x direction it will be different. In y direction it will be taken as same. Okay, it will be taken as same. Now what will be there? You see here again, when we are adding, change in momentum we are finding. So again these two will get added, like minus mu cos 30 degree, and then again minus mu cos 30 degree. So which is giving to you minus 2 mu cos 30 degree. Whereas in this case, in y axis, again it will be 0 as it was there in original. Okay, again in this case, so mu sin 30 degree minus mu sin 30 degree, which is again giving you 0. So when it is at an angle of 30 degree in x axis, your change in momentum is minus 2 mu cos 30 degree. When it was moving in the same straight line, it was minus 2 mu. Only angle you have got here cos 30 degree. In y axis at that time it was also changed 0. In y axis here also it is 0. Okay, so what we need to find, what is the direction of the force on the ball due to each ball. Okay, so if it is negative, F force is equal to what? Now tell me, force is equal to ma or mv by t, change in momentum by t, yes or no? Okay, so now what I want to say, that force is equal to change in momentum by time. So change in momentum is minus 2 mu by t. So it means it is in opposite direction. So the force will be in opposite direction. Force will be in opposite direction. Right. Now another case. Here also it is becoming negative. So force will be in opposite direction only. So net force will be in this direction. Right. So opposite. Understood? Okay, note it down. Right. Right, so we'll go next. Good. So let us move to next topic. Conservation of momentum, I have already told you. So total momentum of a system is conserved. Right. Now equilibrium of a particle. A topic is there which is called equilibrium of a particle. So equilibrium of a particle says that if the forces are equal, then what it will be there? So the body will not change its place. The body will not change its place. So you can say that if the body is there like this, some A body is there, you are applying a force here, and it will be at equilibrium only when another force will be acting in opposite direction. Yes or no? F1 and F2. So the body will be in equilibrium only when F1 plus F2 is equal to 0. All the forces acting on the body, if it is 0, then the body will not change. The moment unbalancing of force will take place, then only the body will be changing. Yes or no? Okay. So that only equilibrium of it is there. When it will be there of these two forces, suppose if three forces are there, even if three forces are there, F1, F2, F3. Correct? So in this case also the body will be in equilibrium if all the forces F2 plus F3 is equal to 0. So what it is being followed? It is followed as, you can say, triangle law of forces. So suppose this is one F1, one side of a triangle, another side of a, this is also F2, okay, and this one. F3. Either we can go for triangle law of forces or parallelogram law of forces and we can find. Yes or no? Parallelogram law of forces means suppose this is there which we have already studied. Yes or no? So F1, F2 and suppose F3 is acting in this direction. Whereas this is a parallelogram and this is same. Okay, so F3. Right, so this is called equilibrium of a particle. Now that equilibrium of a particle, suppose X and Y component is there, then for force X component will be added together, Y component will be added together. Like I am telling you, suppose F1, F2, F3 is equal to 0. So for X component, Fx, what you will be writing? Fx, okay. So for 1x, then F2x plus F3x. Similarly, Y component will be there, F1y, F2y, F3y, Z component, F1z, F2z, F3z, all will be together. So Fx component, Fy component, Fz component. Right? Okay, when we will solve some of the questions, then you will understand. Right? Can I have it? Okay. Good. So it is general concepts for equilibrium of a particle. Only you need to understand. That's all. Okay. One question is given. Now example 5.6 will do. In example 5.6, what it is there? That a figure is given to us. See here figure in a nice manner. And it is given that if this is the axis, okay, the axis should not be put in like this, I will be putting it. So what it is given that if like this. Now a mass of 6 kg is suspended by a rope. It is given that a rope is like this and here it is like this, where a mass of 6 kg is attached, right? Suspended by a rope of length 2 meters from the ceiling. So this length is given to us as 1 meter and this length is given to us as 1 meter. Total length is 2 meters. Total length is 2 meters. Now a force of 50 Newton. A force of 50 Newton is applied in this direction. A force of 50 Newton is applied in this horizontal direction at the midpoint P. This midpoint is P. What is the angle the rope makes with the vertical? So this is the vertical. So what is the angle this rope, this particular rope is making? You can say 0 degree with the vertical. Here only angle is being made. So what is the angle this rope is making with the vertical? In equilibrium. This system is in equilibrium. Okay. So this system is in equilibrium. Right. Now this system is in equilibrium. So if this system is in equilibrium, so you can see that this is the mass. And now this mass will be pulled downward. Will be pulled downward. So pulled downward means due to its weight. Weight means what? mg. Mg. And mg mass is given to us as 6. Okay. G. What it is given, take G is equal to 10 meter per second square. We are already given that take G as 10 meter per second square. We are already given. Now due to its weight, you can say this is W. This rope will be pulled downward. So in that, a tension T will be created in this direction, upward direction. There will be a tension T. See, everything is in equilibrium. Equilibrium means if suppose weight will be more and more, so it will break. So something it has to be upward also direction force should be there, na? So when this T will be equal to mg, then only it will be the equilibrium position. That only it is there. Okay. Now here this T. Now this T is working here. Similarly, if force 50 Newton is applied here, again here also this T will be acting. Correct or not? So this same T will be acting in this direction. Yes or no? So if you need to draw a free body diagram, what it is called? Free body diagram. After this, we need to draw a free body diagram. Free body diagram, that is free body diagram. Okay, in this free body diagram, what you are showing? You are showing that one side this P force is working, not P force, a force any name you give, and that is called 50 Newton. That is 50 Newton force is acting in horizontal direction, and the weight is acting in this direction, mg. Yes or no? Okay. Now this mg is being counteracted by what? Suppose this is T1 and this is T2. This is T1 and this is T2. Now this T1, okay, you can say that it is acting in this direction, T1. So now what it is there? For this mg, here it is T1. Now another tension is also there here. Another tension at an angle. So this is T2. Now for this T2, this component will be here. Okay, so this is theta. Now what it is there? Now this T2 will be split into two parts. This T1 is equal to mg. This T1 is equal to mg. Yes or no? Okay. So this T1 will be mg. And mg is what? M is already given to you 6 into 10. So 60 Newton. So downward direction, what it is? 60 Newton. So your T1 has become 60 Newton. T1 has become 60 Newton. Okay. Now this T2 force at an angle, whenever something is at an angle, it will be split into two parts, two components. One component is this one and another component is this one. Yes or no? Another component will be this one. Now wherever that angle is there, that part becomes cos theta. That part becomes cos theta. Another part becomes, so this is acting in this direction, so this is acting in this direction. Yes or no? If this will be, so now once suppose this mg is over, T1 already it is there. So what you can write? You can write that T1 is in this direction, leave that mg. Why mg we are leaving? Because we came to know that this T1 is equal to 60 Newton. Now this T1 is working in this direction, this T2 also will work in downward, so upward direction. Upward direction. Why upward direction? One is downward, so another one is upward, then only it will be equal. Okay, so now this component is T2 cos theta, this component is T2 sin theta and 50 Newton. So you can write that T2 cos theta is equal to T1, then only equilibrium now. So at equilibrium, this T2 cos theta is equal to T1 and this T2 sin theta is equal to 50. Yes or no? Yes or no? Understood? Okay. Now this T2 is not with us. T1 is already given 60 Newton, correct? Okay. So T2 cos theta is equal to 60. T2 sin theta is equal to 50. Right? Now we need to find what? We need to find this angle only now. Here we are not given that you find T2. We need to find angle. Okay, suppose this is 2, equation 2 and this is equation 1. Now what we'll be doing, we'll divide equation 2 with 1. Divide equation 2 by 1. Why I am dividing? Because I want to find tan theta. I want to find tan theta. You can divide 1 by 2 also. You will get cos theta. No issue. So we want to find tan theta. So T2 will get cancelled. It means T2 sin theta divided by T2 cos theta. Okay, let me write at the top. So it means T2 sin theta by T2 cos theta is equal to 50 by 60. Yes or no? This T2 has got cancelled. So 10 theta is equal to 5 by 6. It means theta is equal to tan inverse 5 by 6. Leave it here. If any angle is given to you in question, okay. Otherwise you can leave here itself. Your answer will be correct. Okay. Right. Note it down.